This section is 4.1, multiplying rational numbers. Okay, so the first thing we're going to do is work on multiplying decimals. So we've got our rules listed here. So it says first thing we're supposed to do is line up numbers on the right side. Do not line up the decimals. Okay, so before, when we did add subtract, we lined up the decimals. That doesn't work for multiply. So for multiply, we don't line up the decimals. We're going to push all the numbers as far as we can to the right. Then what we do is we multiply the same as we would with regular numbers, so numbers without decimals, whole numbers. And then we're going to add the decimal points for a total number of decimal places of the two original numbers, and then that's how many decimals we're going to put in our answer. Okay, so the first problem we have here is negative 3.2 times 5. Usually with these, I just forget about the negatives and positives till the end, so I'm just going to think of it as 3.2 times 5. So what I'm going to do here is I'm going to take 3.2, multiply it by 5, like that. Notice that I didn't put a decimal point behind the 5 and add a 0 to that, because I don't have to worry about that when I'm doing multiplying by rationals. I'm just pushing everything to the far right. So I push the 3.2 to the far right, push the 5 to the far right. When we did add subtract, so if we were going to add these, we'd do 3.2 plus, and then we would put the 0 with the 5 there. We do not have to do that for when we multiply, okay? That's just when we do add subtract that we have to line up our decimal places. So don't worry about that for multiplying. So then what we do is we just multiply this like we usually would with numbers. So we're just going to do 5 times 2, which is 10. So you put a 0 down there, carry your 1. Then you would do 5 times 3, which is 15, plus 1, which is 16. And then what we do for our decimal point, instead of just dropping it straight down, what we do is we look at the total number of decimal points that we have in both of these numbers. So like here with the 3.2, we had one number behind the decimal, right? Here with the 5, the decimal would be behind the 5, so there's no places behind the decimal point. So since there's only one place behind the decimal point, what we're going to do is we think of our decimal currently at the back. We're going to go over one position for our decimal in our answer. Okay, so really we'd have 16.0, or that's the same as 16. And then if we go back to our problem, it was a negative times a positive, so those have different signs. So when we multiply two numbers with different signs, it always comes out to be a negative. So negative 16 would be our answer there. And I always think on these, if I'm having a hard time remembering where to put the decimal point, I think of these as just like regular numbers. So if I've got a number that's, around 3, so 3.2 is kind of around 3, rounds down to 3, and then this is 5. If I took a regular 3 times a regular 5, 3 times 5 is 15, so it would kind of make sense that my answer is a little bit bigger than 15 because I had to round the 3 down. So if I was just kind of using logic here, it would make sense that it's 16 as an answer, instead of if we left it as 160, that would be way off from 3 times 5. So you can kind of use logic and reasoning to help you figure out where your decimal point goes as well. Okay, so our next one here, we've got negative 4.7 times negative 0.4. So again, we're going to push everything to the far right. So we're going to do 4.7 times 0.4. And in this case, the decimals did line up, so that's not wrong, but they don't have to line up, okay? Because like on that last one, they didn't line up with each other. This one they do, but they don't have to be that way. It's just a coincidence. Okay, so now what we do is we do our multiplying like usual. So we're going to do 4 times 7, which is 28. So I put my 8 below, carry my 2. Then I'm going to do 4 times 4, which would be 16. Add that 2, which would be 18. And then here, I'm going to count my decimal places again. So here I've got one position behind the decimal. Here I've got one position behind the decimal. So I've got one here and one here, which makes 2. So when I go to write my answer in here, my decimal is currently behind the last 8. I'm going to go over 2 places. So 1, 2. So my answer for this is going to be 1.88. And then if I took a negative times a negative, well, negative times negative is a positive, so you could put a positive there, or you could just leave it as 1.88. And then kind of using our logic, here we've got a number that's a little bit lower than 5, so if we round that up to 5, Here, 0.4 is kind of around a half, so if we took 5 times a half, that would be 2.5. And since we rounded both of those numbers down, it would make sense that this number is less than 2.5, okay, instead of 188, because if you took 4.7 or around 5 times a half, 188 would make no sense. So that would be kind of logical that it would make 1.88. Okay, so on page 140, try out A through C, and then we'll talk through those. So for A, they got 6.5. For B, they got -18. And for C, they got -25.6. Okay, so hopefully you got those ones. Alright, we'll jump to the next page here. So the next page, we've got a little bit of a story problem. So it says, use the equation H is equal to 12,000 plus 0.5 times -32.1 times 140, or 144, to find the skydiver's height after 12 seconds of free fall. Okay, so I think that there's a problem in the book that also kind of talks about this. It says a skydiver jumps from 12,000 feet, so that's where they're getting that number from. And then they kind of do some stuff. Oh, they say 24 seconds in there. And there's, I don't know where they put the 24, but this problem's kind of from the book too. So if you're looking for where this comes from, there's a problem like it on page 140. Okay, but anyways, so we're going to look at this here. So we want to find our skydiver's height after 12 seconds of free fall, and we're going to use this equation here. So we are going to take H is equal to 12,000. I'm just going to rewrite the problem out. 32.1 times 144. Okay, so with a problem like this, we're going to want to use our order of operations, which was parentheses, exponents, then multiply, divide on the same step, and add, subtract on the same step. So we've got parentheses here, but there's nothing really to solve inside parentheses. Then we go to exponents. We don't have any exponents. Then we go to multiply and divide, which we've got a couple different sets of multiplying here. So we want to work them like we read a book. So like we got parentheses, exponents, multiply, divide, add, subtract. We work them from left to right. Okay, so if we've got more than one multiply or more divide kind of left in that problem, we work them like we read a book. So we're going to start with this one here. So I'm going to take 0.5 times -32.1. So I'm just going to do that off to the side here. So I'm going to put the 32.1 on the top times 0.5 or just 0.5. I'm going to multiply that out. So I'm going to take 5 times 1, which is 5. 5 times 2, which is 10. So put the 0 below, carry the 1. 3 times 5 is 15, plus that 1, which would be 16. And then here I'm going to look at my places. So I've got 1 decimal place there, 1 decimal place there. So total that's 2 decimal places. So I'm going to go over 1, 2, and end up with 16.05. So those two multiplied together was 16.05. Then I also need to look and go, okay, I've got a 0.5 that's positive and a 32.1 which is negative. So a positive times a negative ends up being a negative. Okay, so I've got that. Now I'm going to drop down the rest of my information I've got here. So 144 there plus 12,000. I'll drop down the equals 8 equals H as well. Okay, so now going through my problem, still no parentheses, still no exponents. So now I'm on multiply divide again. So I've still got multiply here because I've got -16.0 times 144. So I have to do that before I get to my add subtract stuff. So this is going to be kind of a big number to multiply here, but I'll show you how to do it. I'll do it right here where I got some room. So I'm going to do the 16.05 on the top because that's got more numbers times 144. Now when you do this, basically you're going to take the 4 times everything on the top, then you're going to cross it out, take the second 4 times everything on the top, cross that one out, take the 1 times everything on the top. Okay? So we're going to take 5 times 4, which would be 20. So 0 below, carry the 2. Then we're going to do 4 times 0, which is 0. But then we're going to add that 2 to it, so 2. 4 times 6 is 24. So put the 4 there and carry the 2. And then 4 times 1 is 4, plus the 2 would be 6. Then, like I said, we're going to get rid of the 4 now, and we're going to multiply by the 4 that's in the 40s position. And since that 4 is in the 10s position, or actually is representing 40, we have to add a 0 down here to make it so it's times 40 instead of times 4. I'm also going to cross out those little 2's up there so I don't get confused by those. So I'm going to take the 4 times 5, which would be 20. So 0 below, carry the 2. 4 times 0 is 0, plus the 2 would be 2. 4 times the 6 is 24. So 4 down below, carry the 2. And then 4 times 1 is 4, plus the 2 would be 6. And then same thing, cross out the 4, cross out those 2's. And then this 1 here is not 1, it actually represents 100 because it's 144. So I'm going to add 2 zeros when I multiply by 1 here. Then I'm going to take 1 times 5, which would be 5. 1 times 0, which would be 0. 1 times 6, 6. 1 times 1, 1. Then what I do is I'm going to add all of those together. So I've got all zeros there, so that's going to add to 0. 2, 0, and 0 adds to 2. 4, 2, and 5 adds to 11. So I put a 1 there. Carry my 1 for the tens position. Then I'm going to do 1 and 6 is 7, plus 4 is 11. So 1 down below, carry my 1. And then 6 and 6 is 12, plus 1 is 13. And then when I carry my 1, 1 and 1 is 2. So I got a big number there, but then I also have to count my decimal places, which in this case I've got 0.05, so I'm going to go 1, 2 places there. This was 144, so there's no decimal places there, so I'm just going to go over 2 places. So my decimal's there, I'm going to go 1, 2. So my number I'm going to have here is going to be 2,311.20, or just 0.2. So I'm going to write that back up here in my problem. So 2,311.2. And then since I took a negative times a positive, that'll be a negative. Then I'm going to drop down my 12,000 plus, drop down my h equals as well. Then I'm going to have to take and I'm going to add those, and since they're different signs, so one of them being positive, one of them being negative, I'm actually going to subtract those values. So I'm going to do that off to the side as well here. So I'm going to put my bigger number on the top, 12,000. And then here, I want to line up my decimal places, so when I write it here, I'm going to go 2,311. And then there's a 0.2 there, so I'm also going to have to put a 0.0 there because I'm doing subtract. So add, subtract has different rules than multiply. Okay, so I had to line up those decimal places there. Then I'm going to have to do some borrowing here. So what I'm going to do is, instead of having 2,000 here, I need to make a 1 here to make that a 10. So instead of the 2,000, I'm going to, since I'm taking 1 away from that, I'm going to make this 1,999, because that would be taking 1 away from that 2,000 number. So I put my 1 there so I can subtract now. So if I do 10 minus 2, that would be 8. 9 minus 1 is 8. 9 minus 1 is 8. 9 minus 3 is 6. 1 minus 2 I can't do, but if I think about that as an 11 instead, 11 minus 2 would be 9. And then when I do add, subtract, I'm going to drop my decimal point directly down. So this will be 9,688.8. So h is equal to 9,688.8. And then I also want to check to make sure I've got the right sign there. So I've got 12,000 and a negative 2,311.2. So I take the sign of the bigger one, which would be the 12,000, so it would be positive that number. Okay, And then we're talking about height, which I don't know what our height is there. I don't know if it even says. It probably says in the book somewhere. What do they have? Feet is what they're measuring in. So that many feet. Okay, so next stuff here, we are going to get into multiplying fractions. Okay, so when we multiply fractions, this is actually easier than decimals. A lot of times fractions can be difficult, but when we multiply fractions, it's actually a little bit easier than the decimals. So basically what our rules are is we're going to change any mixed numbers, so where we have like a 1 and a half or something like that, where you got a whole number out front and then a fraction, we're going to change those to improper fractions if we have any of those. Next thing we're going to do is we're going to see if we can reduce it all, and when we reduce, we go the crossways, which I'll show you. Then what we do is we do top times top and bottom times bottom, and then if there's anything at the end that we could reduce or change, we can do that as well. Okay, so looking at the first one here, we've got 2/7 times a negative 3/5. So we don't have any mixed numbers here, so like where we've got a whole number and a fraction, or just a whole number by itself, we don't have any of that stuff, so we don't have to worry about that. Next thing we check is to see if we can reduce. So when we reduce, we're looking the crossways here. So I'm looking at the 2 and the 5 and the 3 and the 7. So if I'm comparing the 2 and the 5 and I'm thinking, okay, is there a number I could pull out of both of those? Well, 2 is prime and 5 is prime, so there's nothing I could divide both of those by to make them smaller. Then I check the 3 and the 7. Those are also prime, so there's nothing I can pull out of those either. So there's nothing I can reduce there. So now I'm just going to take the top times the top. So 2 times the 3, which would be 6. Bottom times the bottom. So 7 times the 5, which would be 35. And then I took a positive times a negative. So my answer would be negative because they have different signs. Then at the end, I always check to see if I can reduce again. Well, there's nothing I can pull out of both of those. So that would be my answer, -6/35. Next one here, I've got -8 times a -3/7. So here I've got a whole number, -8. To turn that into a fraction, I'm going to put it over a 1. So -8/1 is the same as -8. Now I see if I can reduce. So the -8 and the 7, nothing I could pull out of both of those to make them smaller. 1 and 3, nothing I can pull out of those or divide by those to make them smaller. So now I just do top times top. So 8 times 3 would be 24. Bottom times bottom, 1 times 7 would be 7. And then if I take a negative times a negative, same signs, it's going to become positive. So positive 24/7. And then if you want to, you can change this to a mixed number by seeing how many times 7 can go into 24, which would be 3 full times at 21. And then if I do 24 minus 21, I have 3 left. So I would have 3 out of 7 left. So you could either write 24/7 or 3 3/7. I would take either of those answers on the test. Oops. Alright, next one here. I've got -3 1/3 times 1/7. So here I've got an improper fraction where I've got a whole number out front and then a fraction. So first thing I want to do is I want to turn this to a mixed number. So what I do there is I'm going to take 3 times 3, because that's saying 3, like if you're thinking about it as pizzas, 3 whole pizzas cut into groups of 3 or cut into 3 slices would give me 9 total slices for 3 pizzas. Then I've also got a part of a pizza, 1/3 of a pizza, so 1 piece of the cut into 3 sections. So if I do 3 times 3, that's 9. Then I add my last piece there, which would be 10/3. So -10/3 times 1/7. So then again, I'm looking the crossways to see if I can reduce. So I've got 10 and 7. Well, there's nothing I can pull out of either of those. So I'm going to leave those. 3 and 1. Again, nothing I can pull out of those, so I've got to leave them. Then I do top times top. So 10 times 1 would be 10. Bottom times bottom, 3 times 7 would be 21, and then I'm taking a negative times a positive, so that would be negative 10 over 21. Okay, next one here, I've got 15 over 4, so that would be an improper fraction where the bigger number is over the smaller number, times 2 over 5, or 2/5. So first thing I want to do is I want to see if I can reduce it all. So here, 15 and 5, well those will actually reduce because I could take 15 and divide it by 5, and I can take 5 and divide it by 5. So if I pull a 5 out of both of those, 15 divided by 5 is going to change to 3. 5 divided by 5 changes to 1. Then I look the other way, so I've got 4 and 2. Those can also actually reduce because I can pull a 2 out of both of them because they're even. So if I take 2 and divide it by 2, I get 1. If I take 4 and divide it by 2, I get 2. So then since I did all my reducing there, now I take the top times the top, so 3 times 1 would be 3. 2 times 1 would be 2. So 3 over 2, which would be improper. So then what I would want to do to change it to a mixed number, I would want to see how many times that 2 can go into 3, which would be 1 whole time with 1 left over. So 3 over 2 is the same as 1 1/2. Now you might be wondering, okay, couldn't I just take top times top and bottom times bottom and not worry about the reducing? Yeah, you can. You just have to work with much bigger numbers. So if I did that there, it would be, so my original problem was 15 over 4 times 2 over 5. So if we just ignore all the reducing and just do top times top and bottom times bottom, this would be 15 times 2 would be 30. 4 times 5 would be 20. So then I've got 30 over 20, which is kind of a bigger number there. And then I would want to reduce down at the end. So 30 and 20, I could both take both of those and divide by 10. So if I do that, take each of those top and bottom divided by 10, it actually comes out to be that same 3 over 2. So I just like doing the reducing at the beginning so I don't have to worry about as big of numbers there. You can just multiply straight out and then do your reducing at the end, but I think it's easier to do the reducing at the beginning so you're not working with such big numbers. Okay, so on page 142, try out D through F and I'll get you the answers. So for D, they got 15 over 28. E, they got negative 12 over 5, or if we change that into a mixed number, that would be negative 2 and 2/5. And then for F, they got 11 over 16. Okay? So those would be your answers for that. Next thing here, we've got a property, so multiplicative property of negative 1. So that says the product of negative 1 and any number is the number's additive inverse. Okay, so basically what they're saying here is if we take negative 1 times some number, so like negative 1 times 5, we would get a negative 5. Okay, so we've been doing that. You guys know how to do that. Now this whole additive inverse thing, basically inverses are numbers that add together to become 0. So here we've got 5 and negative 5, and when we add them together, we get 0. So that's what makes them additive inverses. So basically a number plus another number that gives you 0 is an additive inverse, and we get that when we multiply by negative 1. Okay, that won't be in the on the test or anything, but that's helpful to know when you get to geometry. Alright, next set of stuff here. So we are going to do multiplying with our fractions and decimals, but they're going to throw some variables in there. Okay, but we've done this before. The only difference is now we've got decimals and we've got fractions. We've done the variable part before. So what I'm going to do to start is I'm going to ignore the variables and I'm just going to take those numbers and multiply them. So I've got 2.2 times 5, and I remember I push everything off to the right. I don't line up decimals here. So then I'm going to take 2 times 5, which would be 10, so 0 at the bottom, carry the 1. 5 times 2, which would be 10, and then since I've got that 1 up there, That would be 11. Then I count my decimal places. So I've got one decimal place there, no decimal places there. So when I go to write my answer, I'm just going to go over one position. So that would be 11. And then since I took a positive times a negative, those are different signs. So negative 11. Now don't forget here, I've also got those variables. So I'm going to take the b and the y and just multiply them together at the end. Okay, I don't have to do anything fancy. I don't have to plug in or anything like that. I'm just going to put the b and the y being multiplied together at the end. Okay, and then logically, if we think about that as well, if we think about this as 5 and this is around 2, if we took 5 times 2, that would be 10. So 11 is pretty close to 10, and it makes sense that it's a little bit above because we had to round the 2.2 down to get the 2. Okay, next one we've got here, we've got 5/7 g times 2/3 h. So again, we're just going to worry about the numbers first. So 5/7 times 2/3. So we look to see if we can reduce. So we've got 5 there, 3 there, nothing we can pull out of those to make them smaller. 2 and 7, again, nothing there, we can make them smaller. So then we do top times top. So 5 times 2 would be 10. Bottom times bottom, 7 times 3 would be 21. So we'll have 10/21. And then it was just two positives being multiplied, so we would have a positive 10/21. And then again, we just put those variables being multiplied at the end. So 10/21 and then the GH there. The last thing here is the closure property. So closure property of rational numbers says the sum, difference, or product of two rational numbers is always rational. So if we took a fraction or a decimal and we multiplied them, we would always get a number that could be turned into either a fraction or a decimal. Now it might not be written as a fraction or a decimal when you actually write it out, but it could be turned into a fraction or a decimal if we needed it to be. Again, not terribly important for what we're doing right now, but down the road in your future math classes, it'll be more important. So that is it for notes. So your book page is 144, 18 to 42 even.